Hello everyone, welcome to Mechanism Design using CREO Parametric 3.0 course. So we are going to discuss about the introduction to mechanism design process. Okay. So first let us go through the objectives of this module. Okay, and then let us get introduced to the mechanism design. Okay. So the objectives of this module is to understand and describe the mechanism design, and then understand and describe the tools available, okay, in mechanism design extension. Okay. Then understand and describe the typical geoparametric mechanism design process. So these are going to be the objectives. Okay. So let us get introduced to the mechanism design. So in the mechanism design extension, it enables you to simulate the kinematic motion in your geoparametric assemblies. So you'll be able to simulate the kinematic motion. Okay. So by defining the mechanism connection between the components, okay, so this enables you to define the mechanism connection between the components, move the connected components using servo motors, and measure changes in position, okay, velocity and acceleration, detect and identify collisions between the moving components, okay, then create trace curves and motion envelopes. Okay, so this mechanism design environment is going to be having mechanism tree and the mechanism tab. Okay, so this is going to be your the typical loader mechanism. Okay, so let us go and check the mechanism design process whatever we are going to discuss. Okay, so the following steps are used as a typical mechanism design process. So we are going to create the model, then verify the mechanism, add mechanism entities, prepare for analysis, and then analyze the mechanism and evaluate the results. So we are going to create the model first by creating connections. So far we have used the constraints. So here we are going to use the connections, and we are going to create the mechanism bodies. Okay, then we are going to use the motion axis settings. Okay, so this is the model. Okay, mechanism model. So this is going to be the axis motion axis definition, and we are creating the pin connection. So we can verify the mechanism. Okay, so once we are creating the model and the mechanism, the second step is every mechanism designed to need to be verified that the connected components move in the manner you intended. Means it has to satisfy the design intent. So we can use a reconnect tool as well as drag components. So first in the assembly we'll be using the drag components, and then we'll be using the reconnect tool which is there available in the mechanism design extensions. Okay. So the next step is going to be adding servo motors. So we have created the mechanism and the model. So to now to drive the mechanism in the model, we need to have kind of motors. Okay. So in this exercise, we are going to use the linear motion. Okay. So this is going to be a servo motors. Okay, because it needs to be not a kind of circular motion, it's going to be a linear motion. So we need to have linear motors, means linear servo motors. Okay. Then we are going to prepare the analysis, uh, prepare for the analysis of a mechanism, like what exactly the purpose of the mechanism design is to uh, you know find out whether the position. Okay, like we will be setting the initial position, and will be the mechanism will be, after driving with the servo motors, is going to move to a certain extent. So how much is the motion, means how much is the x component change, or y component change, whatever the change, what is the initial position and what is the final position. So that we can find out. Okay, in this process exercise we are going to do that. Also we can use the velocity and acceleration changes. Okay, so we are going to analyze the mechanism. means we are going to define the position analysis as well as the kinematic analysis, okay, using the preferences, log bodies, and also by defining the motion. And finally, we are going to evaluate the results, okay, and we are going to analyze the results playback, and also we can find out whether there is going to be any interference, okay, and we can use the measures and graphs to find out, how much is the change in the position, okay, and trace curves also we can use and find out, okay, also create motion envelopes, okay. So these are going to be you know the flow of whatever the analysis we are going to do, okay. So let us just check, the uh, design flow. So we will just go into the actual model, create the model, then verify the mechanism, and follow the steps, adding mechanism entities, preparing for analysis, then analyze the mechanism, evaluate the results. So let us just get into the actual model, okay. So we are going to create a typical model, this kind of loader mechanism, okay. So once we are going to have the loader component uh, uh, be there, it will be having the ground, means it's going to be fixed, and we are going to add components to that, okay. So then what we are going to do is we are going to create the entire assembly like this. We are going to add the arm part, then we are going to add the bucket part, then in order to make the motion happen, we are going to have use the piston assembly, okay. So this is going to be the basic loader assembly, okay, with the ground component created, okay. So let us try to add components to this. So I'll add the assembly. I'll be going to the model tab, and in the component group I'm going to use the assemble, and I'm going to select the arm part, okay. I'm going to select open. So once I get the arm part opened, okay, I'll be having two options, like automatic and it means the constraint and the connection. So here we are going to use the connections. So there are a number of connections available. We are going to use. We are going to start with the pin connection. Okay. So I'm going to you know uh, do the axis alignment, because we need to specify two conditions here. One is axis and one more is translation. So I'm going to use axis alignment. So I'm going to use this surface of the component for the first reference, and then the second component reference I'm going to use this you know this surface, the inside surface. So it is going to get connected like this, okay. For the translation, I'm going to use this surface, and I'm going to use the top surface of the assembly, okay. So the connection definition is complete. I'll say okay. So as I need the rotational degree of freedom, I'm not going to use it, okay. So once I'm done with the the connection created, okay, let me check the component using drag component, okay. So if I'm going for dragging, it has got the rotational degree of freedom, which I have not specified, okay. So I'm going to call the second component, okay. That's going to be the bucket component. So the bucket, say okay, open. So once I'm getting the bucket component, I need to orient the component in such a way that it's going to get assembled properly. I'm going to use Control plus Alt and middle mouse button to reorient it. Okay, so I'm going to disable the 3D tracker. Okay, so I'm going to go for the pin connection. Okay, now to assemble these two ends. Okay, so I'm going to use the surface of the bucket component and this surface of the arm means that is the assembly. Okay, so for the surface means the translation. Okay, I need to give translation reference also, so I'll use this surface as well as this surface. Okay, so I'm going to leave the rotational option as it is. Okay, I'll say okay. So I'm done with the second component. Okay, the bucket component. So now we need to add the piston assemblies, which is going to give the translational means the motion for the assembly. Okay, so I'm going to go for you know so this is going to be the third step. Okay, so I'm going to go for calling the piston assemblies. So I'm going to call the piston assembly 1. Okay, so I'll say open. So I need to specify the the connections for both the ends here, because it is going to have you know two ends, like uh, whatever so far we assembled had only the one end connection, but in this piston assembly we are going to have two ends. Okay, so I'm going to reorient using control plus alt and middle mouse, so that it's going to have orientation like this. Okay, so I'm going to go for pin connection. So select this surface. Okay, then you will select the inner hole. Okay, and for the translation, okay, I'm going to select this surface as well as the outer surface of the assembly. So notice that the first end is assembled with the pin connection. The second end we need to specify one more connection. So either I can use the new set in the dialog box, okay, the placement dialog box, or I can right click and then say add set. Okay, so I'm going to use the add set, and then I'm going to select this surface as well as this surface. Before that I need to change it to cylinder connection. Okay, so I'll change it to cylinder and select this surface. Okay, so this is my first uh, reference. The second reference is going to be this one. Okay, so now the definition is complete. Okay, I can say yes to this, so it is connected. Okay, now let me call the second piston assembly. Okay, so reorient the component in such a way that it's going to be assembled between the bucket and the arm. Okay, so I'll use the pin connection over here. Select these two surfaces. First reference is this. Okay, or I can go for selecting the other end, because this end needs to be connected to this end. Okay, so I'll just select this reference. Okay, and for the assembly reference I'm going to select the bucket surface. Okay, so for the translation I'm going to select this surface to be mated with the inner surface. So it's going to be assembled like this. Okay, so notice that the first end is connected, the second end needs to be connected with uh, one more connection set. Okay, so either I can go for right clicking and say add set, or I can go for new set. Okay, so this is going to be a cylinder connection, so I'm going to use this surface as well as this is the component reference, and this is going to be assembly reference. So the connection definition is complete. So I need not have to uh, give the translation and rotation because I want this to be free. Okay, I'll say okay. Now this is done. Okay, so once this is done, okay, we can check for the mechanism. So the model. Okay, so I can use the drag components in the component group. Okay, in the model tab. Okay, so I'll select the drag component because I need to, you know, uh, verify the mechanism. I am done with creating the model. Okay, and I need to verify the mechanism. Okay, so I'll just click on the piston 1 assembly surface and just drag the component, and notice that I am able to freely move. Okay, my design intent is getting satisfactory with the the what are the movement I'm making. Okay, similarly I can select this yellow component and you can check like this. So my design intent is uh, getting you know uh, satisfied. Okay, so this is one way of checking the the mechanism. Okay, the connections. Okay, so let us regenerate the component and then orient it to the front orientation, so that we will go into the mechanism design extension and use the reconnect tool. Okay, so we are giving the double check means I'll go into the applications. Okay, then mechanism and use the reconnect tool which is there available in the mechanism tab, bodies group. Okay, reconnect. I'll run uh, the mechanism. Okay, and it is saying that it is giving confirmation that the mechanism assembly succeeded. So whatever the mechanism connections we have created is correct. Okay, okay, so I can go ahead. So do you want to accept the assembly configuration and reposition of the bodies in the database? I'll say yes. Okay, so I'm done with checking the mechanism which is right. Okay, which is working. Now I need to you know if I want, I can make some changes to the already created mechanism. Like, I can go into the connections, I can go to the joints, and in the joints, I can go to the piston. So this is again a mechanism. Okay, the piston 1 and piston 2 are two mechanism assemblies that has been created with slider connection. Okay, so let us try to modify the distances. Okay, so by default it has been specified as 120, the distance between the the outer cylinder and the piston. Okay, so I'll try to change this to 50, see what happens. It is not getting changed. Why? Because this has been defined with the minimum distance of 80 and the maximum distance of 120. So I need to define this at least 80. So I'll define this as 80 and press enter, and then say set this as the regeneration value, and then say okay. So I'm doing kind of modifications over here. Once I'm defining the mechanism, it is possible for us to modify this. Okay, So I'll go to the piston 2 assembly, then translation axis, and edit this. So this is having 300. So the maximum distance that is possible is 350. So let me set it to that 350, and then I'll say means set the value, regeneration value. I'll say okay. So it is done. Okay. So two possible changes we have made in the piston 1 and piston 2. Okay. So now we are done with the entire, uh, the creating the model, okay, and then verifying the mechanism, okay, and modifying, okay, modifying the mechanism. Okay. Now the next task, the next step is going to be creating the servo motors. Okay. So we'll go to the mechanism tab, and in the insert group we have got the servo motors. So let us define the servo motors. Okay. So we need to have translational motion for the piston 1, piston 2. Okay. So let us select this, you know, this axis, so that it's going to make the downward movement. Okay. So let us define the profile for this. So we are going to specify this as velocity. Okay. Then it's going to be magnitude of constant. Okay. So you have got a lot of options over here. We are going to use the constant as the option, and we are going to define the constant as A as 6. Okay, and say okay. Okay. So the first servo motor is defined. So we need to specify the second servo motor. Define the servo motor for the the other piston assembly also. So we are going to define this axis. Here it is showing downward arrow. Is going to make downward movement, which is not required for us. We are going to flip this so that it's going to make upward movement, because this has been defined already as downward movement. Okay. So I'll go to the profile. Okay. Then change the specification to velocity, and this, since this is going to make a parabolic movement, we are going to define the magnitude as the parabolic. Okay. And define the constant as 0.008. Okay, and press enter. Okay, so I'll say okay to this. Now we are done with creating the servo motors. Okay, the servo motors have been defined. Okay, so we need to go for creating the measures. Okay, so we are done with the adding of servo motors. Okay. We use the motion axis of a connection. Okay, now we are going to prepare the model for analysis. We are going to prepare the mechanism for analysis. Okay. So we need to specify the initial position. We are interested in doing the position analysis here. So we are going to define the position. Like I'm going to go for measures. Okay. I'm going to define a new measure. Okay. And if you notice, there are class over here in the bucket. So I'm going to use the endpoint of the bucket class as my default position. So I'm going to go for front orientation, and I'm going to select the endpoint of the class. Okay. So now it is going to be with respect to the world coordinates, the default coordinate system. Okay. So the magnitude is going to be x component, and the evaluation method is going to be the maximum method. Okay. I'll say okay to this. So this is my measure. Okay. So what I'm going to measure? So running this analysis, what I'm going to measure is the change in the x component. Okay. I'll say okay to this. I'll close this. So I'm done with the measures also. Okay. Now I'm going to go for the analysis. Okay. So I'm going to define the analysis. So the name of the analysis is going to be analysis definition 1. and the type of analysis I'm going to make is going to be, the kinematic analysis. Okay, the start time is going to be 0, the end time is going to be say 50. Okay, so with this definition, I'm going to run the analysis. So I'll say run. Okay, so that is going to go through the movement. Okay, so whatever the servo motors that has been defined, is going to drive the mechanism, and it is going to make the movement like this. Okay, so I close this, and I notice that it is still left with the movement. Okay, so I'll just go to the analysis and then say definition and then run again. Okay, so I'm going to say yes, so that it's going to make the motion completed. Okay, so I'll abort here. Okay, then I'll just change it to uh, you know I'm going to regenerate, so that it's going to regain its original position. Okay, and I'm going to do the analysis again, because with whatever the definitions we have made, how much the mechanism is going to move the bucket, which is going to make the parabolic motion. Okay, so I'll just going to go for the analysis again. Okay, select this and then say run again. Okay, so I'm going to say yes here, so that it's going to move like this. It is going to complete the motion. Okay, the parabolic motion, because of the two motors whatever we have defined. Okay, and then we are going to measure what is the distance it has moved, because the the claw point was somewhere here and now it has been moved here. Okay, so I'll go to the measures. Okay, and click on the measure here, and whatever the analysis definition we have done, we have to click that, so that it's going to specify how much is the distance. So 2748.27 is the distance. It is showing the point also over here. Okay, so I'll close this. So this is how we have done the analysis. Okay, so for this, you are going to get the playbacks created. Okay, so I'll go to the playback. So in the analysis, we will not be able to zoom, okay, spin and pan. Whereas in the analysis, in the playback, we can go for you know playing this. Okay, so it is going to give us the animated uh, uh, movement. Okay, so that I can play this. So I'm going to play this. So I'm going to increase the speed. Okay, so during the playback, I'll be able to zoom it. Okay, this kind of zooming will not be possible in the case of the just analysis. Okay, as well as we can spin the model. Okay, as well as we can zoom the model. Okay, as well as I can pan the model. Okay, so this kind of orientation change is possible in case of playbacks. Okay, so I can close this. So so we have done the positional analysis. Okay, so change in the position. Okay, so this is going to be the value 2748.27. Okay, so this kind of positional change we can find out, as well as we can go for saving this also. Okay, so I can save this as playback dot pbk. Okay, as well I can change, and I can save the entire file by going to the file save. Okay, I can make a save. Okay, so this is how we are going to create the mechanism design. Okay, process exercise where we have done the positional analysis. Okay, so hope this video has given a fair idea and knowledge about the CREO parametric 3.0, mechanism design process exercise. Okay, so with this we are coming to the end of this video. Okay, so uh, thanks for watching this video. See you in the new video. Thank you.